Now, functions and relations can be represented through the following: set of ordered pairs, table of values, mapping diagram, and graph. So let us recall the Cartesian coordinate plane. The horizontal line is the x-axis, the vertical line is the x-axis. It is divided into 4 quadrants: the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now let's recall the sign of each coordinates in each quadrant. For quadrant 1, the sign of x here is positive and the sign of y is positive. X moves to the right, y moves up. So that is positive, positive. For quadrant 2, the sign of x is negative and the sign of y is positive. X goes to the left, all values to the left are negative, y moves up, all the values going up are positive. For quadrant 3, the value of x is negative and the value of y is negative. So x is negative, y is negative. X moves to the left, negative, y moves down, negative. For the fourth quadrant, the value of x is positive and the value of y is negative. X moves to the right, all numbers to the right are positive, y moves down, all values going down are negative. So let's have this example number 1. Let us represent this through set of ordered pairs, table of values, mapping diagram, and graph. Now, the first one that we're going to do is a table of values. So we're going to assign values for x to get values of y. Suppose our x is negative 1, 0, and 1. So you can use any values for x. So I use negative 1, 0, and 1. So we have 3x plus y is equals to 1. So let's write this in function 4. So we have y is equal to transpose this. So we have negative 3x plus 1. So now, if our x is negative 1, just substitute negative 1 in the variable x. So we have y is equal to negative 3 times negative 1 plus 1. Y is equal to negative times negative is positive. 3 times 1 is 3 plus 1. Now y is equal to 4. So when your x is negative 1, y is equals to positive 4. So let's use this function. Y is equal to negative 3x plus 1. If our x is 0, so we have negative 3 times 0 plus 1 is equal to negative, is equal to 3, negative 3 times 0 is 0 plus 1. 0 plus 1 is 1. So when your x is 0, your y is 1. Last one, y is equal to negative 3x plus 1. Sorry. Okay, plus 1. Y is equal to negative 3 times 1 plus 1. This is now negative 3 times 1 is negative 3 plus 1. So negative 3 plus 1 is equals to negative 2. Now, when your x is 1, your y is negative 2. So how are we going to write this in the set of ordered pairs? Let us erase this, please. Erase. Okay, the set of ordered pairs, this is now negative 1, 4, 0, 1, and 1, negative 2. This is x, 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 y, y, y. So how about in mapping diagram? So just draw 2 circles or any shapes that you want. So mark this as x and the other one is y. Then write all the values of x in the set x. So we have negative 1, 0, and 1, and all the values of y here, 4, 1, and negative 2. So negative 1 is paired to 4. So just draw an arrow pointing negative 1 to positive 4, 0 to positive 1, 1 to negative 2. And this is what we call a 1-to-1 relationship or relation. So 1-to-1 relation is a function. So how are we going to graph this 3x plus y equals 1? We already have the table of values, the set of ordered pairs, and the mapping diagram. So let's have the Cartesian plane. Again, the horizontal line is the x, the vertical line is the y. So we can use either the table of values, the set of ordered pairs, or the mapping diagram. So how are we going to do this? So let's make use of the set of ordered pairs. So negative 1, 4. The value of x is negative 1. This is the negative 1. And y is 4. 4 is here, positive 4. So negative 1, positive 4. So draw a dot. Next, we have 0, 1. So this is 0 of x. This is 1 of y. Draw a dot. 0, 1. Now, next, 1, negative 2. This is 1. Y is negative 2. Okay, then draw a straight line. Okay, so we have now the graph. So we already represented this equation through table of values, set of ordered pairs, mapping diagram, and the graph. Now let's have this example number 2. So the given is negative 4x squared plus y squared equals 9. So again, we're just going to rewrite this into function form. We have negative 4x squared plus y squared equals 9. So to make this function form, just transpose this. So we have y squared is equal to negative 4x squared. Sorry, negative becomes positive. So negative 4x. So transpose, we have now y is equals to, transpose y squared is equal to 4x squared plus 9. So to remove squared in y, so we're going to raise both sides of the equation by 1/2 or by the square root. So cancel this, so we have y is equal to the square root of, positive negative square root of 4x squared plus 9. Now, let's assign values for x. So we have x and y here. Let's say our x is 0. So when your x is 0, we have y is equal to positive negative square root of 4x squared plus 9. So 9. Then x is 0, just substitute. We have positive negative square root of 4 times 0 squared plus 9. Okay. So 0 squared is 0. 0 times 4 is 0. 0 plus 9 is 9. So this is now equal to positive negative square root of 9. And the square root of 9 is positive negative 3. So for 0, we have now here negative 3. And 0, we have positive 3. So how about if our x, let's say, is 2? Okay. So for x equals 2, so just do the same. Y is equal to positive negative square root of 4x squared plus 9. So we have positive negative square root of 4 times 2 squared plus 9. So let's move here. So we have positive negative square root of 4 times 2 times 2 is 4. 4 times 4 is 16. Okay, so we have here 16 plus 9. So positive negative square root of 16 plus 9 is 25. So y is equals to positive negative. So we have here positive negative 5. So meaning when your x is 2, we have two values, negative 5 and 2, positive 5. Okay. So how are we going to write this in the set of ordered pairs? Erase, erase, erase. In the set of ordered pairs, we have here 0, negative 3, 0, 3, 2, negative 5, and 2, 5. So in mapping diagram, so just draw two circles again or any shapes that you want. So mark this as your x and mark this as your y. So write all the elements of x here. So we have 0 and 2. And all y's here, we have negative 3, positive 3, 2, negative 5, and 5. So map, we have 0, map to negative 3, 0 to 3, 2 to negative 5, 2 to positive 5. So this is what we call a one-to-many relation. And a one-to-many relation is not a function. Now, how are we going to do this or to graph this? Let me just erase this first. Again, this is a one to many relation, and this is not a function. So are we going to graph this? So let's use of the table of values. So 0, -3, 0, 3. Next, 2, -5, and 2, +5. So the graph looks like this. Okay. I just do not know the vertex. What is the vertex? Okay, so the graph looks like, so this graph is not a function. So when you say graph, how are you going to identify whether a graph is a function or not? All you have to do is to draw a vertical line. This is what we call a vertical line test. When it intersects more than one point on the graph, it means that it's not a graph of a function. Again, draw a vertical line. When it intersects more than one point in the graph, it means this is not a function. Thank you.